This is a short talk about conservation of energy. The conservation of energy is actually very similar to things we've already discussed. We discussed energy transformation, how if we start out with 100 joules of energy, let's say potential energy, and then our object starts moving, it all transferred over to kinetic energy. We have actually already been using this. The fundamental energy work theorem is energy initial equals energy final, but there are times when work is involved. This is the approach I would take when I have friction involved. Now, if there's no losses like friction, that term turns to zero, and you are just left with how we were doing the energy transformation equations. So we've actually already been doing this, we just didn't call it conservation of energy. So, for example, let's say we've got a ramp, there's a height, and I have a block sitting here of mass m. Let's say I really want to know how fast is it going when it reaches a height 2? Maybe that's the question I'm asking. Alright, so this is what I do. I set it up. Energy initial equals energy final. So in this case, the first condition is just potential. But look down here. It's at this point. It has a height, so we have to count the height. But we also are moving. So we have kinetic energy involved. From here, we would sub in mass, gravity, height 1, mass, gravity, height 2, 1/2 mass, velocity squared. But this is the approach we take for conservation of energy. I'll do another example set up in just a moment.